Hold on. Okay, we are on lesson 3.4 for math. Lesson 3.4 is graphing ratios relationships. Alright, where we are at. You're saying you probably need to do this. You're not blocking there. You can work at that table if you like. Okay, where we are at is our first lesson. We learned to identify a ratio. We were given a certain circumstance, and we identified a ratio. Something like, hey, there are three. Zoom just a little so it shows it better. And we had 3 boys for every 2 girls. Okay? This was lesson 3.1 that we worked on. We learned to identify ratios. When we went to lesson 2, we learned to use a tape diagram to model this ratio like this and find out the answer for different parts or different totals. In lesson 3, we continued to work, and this time we went with ratio tables, in which we used to identify equivalent ratios. That could do 18 over 12. Okay? So that's what we've done thus far. We've seen how we keep growing with ratios. We just take it to the next level. And a lot of times these have to come off of each other. Okay, what we're going to do today is we're going to take a coordinate grid that has points down here, points up here, and we're going to look at our ratio table, and we're going to identify coordinates. And then we're going to graph them, and we're going to be able to connect them into one straight line. So, this is our progression. After today, you should be able to identify a ratio, draw the ratio table to find missing parts, do a tape diagram for the missing parts, do a ratio table to find equivalent ratios, and then graph. Today is Friday. When I get you on Tuesday, we are going to be reviewing. You'll need your notebooks. We're going to put some cheat sheets in our notebooks. We are going to do stations to review each one of the lessons. We'll have activities for us to do. And then we'll have our study guide. And then on Thursday of next week, you will take your quiz over lessons 1 through 4. So it'll be an 80% grade. We'll start with lesson 3.5 then that following Monday. Okay? Any big questions? Where we're at or where we're going? Alright, so let's get started with your exploration. Turn to page 72. We're going to go to exploration 2. Okay, you're going to work with a partner, which is our
table.
You're going to look at your graphs. There's 2 of them. They're the same. They just mark something different on them to make a ratio table. If you would go ahead with me and draw this to the side. Let's say milk. Let's say cereal. Okay. So, what I need you to do Alright. So, I want you to work with your group, look at this graph, and you need to complete this table. I need 3 equivalent ratios that you can identify from this graph. Alright? Any questions? Alright, turn, work with your group. Okay, let's see what we got. So what is one of my first ratios that you guys were able to find? Anastasia? Okay, 5 milks, 2 cereals. What is the second one? Everett?
I disagree.
Alright, why?
Because the first line is 5 to 0.
Nope. Now, you have to think about this. If my ratio is 5 to 0, all your cereals would have to be 0.
It'd be 5 to 1. Because like half of 10
Okay.
is 5 to 1. Just straight up over it.
Well, hold on. Maddox, are you sharing something that you need to be? Okay, I'm trying to talk. You're supposed to be listening and following along. So if you said 5 to 0, then cereal would always be 0. It means we don't have any cereal. Because if 5 milks equals 0 cereal, 10 milks would equal 0 cereal, and so on. We keep adding by that. If you said 5 to 1, how did you get 5 to 1? Where's it at on the graph?
So if you go up where you are, you're at 5 2. Which, like, if you added the bottom 5, it'd be 10 to 2. And half of 10 to 2 is 5 1.
Okay. But it's not, because if we look at this graph shows me right here on this line, this point, oops, I want to do it with blue. That point is located at the coordinates 5, 2. If we follow this, our next one should be at 10, 4, because here's our next coordinate point. And then we have our last one, which is at 15, 6. Now,
Oh, I thought we were counting at the end of the arrow.
well, we kind of are. Now, what we are starting at is 0, 0, and it shows that we went over 5. What is that representing? Mason?
That is 5 fluid ounces of milk.
That's where we start at right here. It shows each time we're adding 5, that shows what we're doing up here in our numerator. That's the first part of our ratio. When we have the plus 2 each time, that's the bottom half of our ratio. Remember, if we add on our ratio table, we add by our ratio. 5 over 2, we add 5, we add 2. Now, an important thing to note is on here, I'm going to erase these other points just so it's a little more clear. When we list a coordinate, anytime you list a coordinate, you list the x coordinate first and then the y. We do this, it's a rule of math, that way everyone has the same coordinates and we know what we're talking about the same. Now, x and y, what is that? On our graph, you think of, hey, we have this graph with all this information. Maybe I have this one, maybe I have it. This one has a lot of information, right? We have 2 axes. We have an x-axis and a y-axis. The x-axis is the bottom one. The y-axis is on top. The way we can remember that is our graph has a lot of information, so it's heavy. And so the x-axis puts up 2 hands to try and hold it. And if you think about it, you're like, oh, well, the y has 2 hands. But if I hold something heavy, would I stand on 1 foot or would you stand on 2 feet? You would stand on 2. If you stand 1, you're just being silly. You would stand on 2 feet. You would get big. So x-axis puts both feet down. He gets big, and he's holding up the whole graph. Zoe even said how her teacher taught him with the y, they said y to the sky. So y is pointing up. Okay? Now, x, y. X is our horizontal, which means it goes left and right. Y is our vertical axis, goes up and down. When I tell you your coordinates, 5, 2, it means 5 over 2 up. 5 over 2 up. So 10, 4 meant we went over 10, and then we went 4 up. Yes?
And a way to memorize that is x comes before y in the alphabet.
Yeah, that's a good one. What you're going to be seeing is with this straight line, we'll get into algebra, and you'll be using this a lot, and you'll see that this will become the slope of a line. One last thing, if you made this table, like you were supposed to, right next to it, you should put this in here. When we have a table, and you'll see this in 8th grade a lot, when you make tables, your first terms on the top are your x terms. The bottom is your y. You can also remember our tables were input, output. Your input were your x coordinates, your y is your output. Okay? It's just something that carries over in math a lot. Alright. What I want you to do, 2 things. I'm going to make a race. And I'll hand out notes in just a second. But, I gotta see if mine works. I need everyone to get to the dashboard of Big Ideas. When everyone in your table group is there, let me know.
Candy. This is the thing about
No, what are we doing?
I'm here. We're here.
Dashboard, dashboard. Everyone in the group there? Nope, you guys can't put your hands up yet because not everyone in your group's there. It's the main page.
What are you doing?
We're done.
Main
There.
Oh, Riley's not in there.
Hers is loading.
No, okay, we're there. Yes, we got it. We got it. We were there.
Why is your computer so slow?
I don't know. It's not working.
It's your fault.
Oh, now she's there.
Your computer's too
I
slow.
was always. She's here.
I know.
Your computer's too slow.
Did you get a faster computer? I don't. I probably ate mine.
Yeah. Alright. What I need everyone to do is click. Guys, this is your first warning. Second warning, we're done. So, if you 4 are going to be goofing around, all 4 of you, I got Bradley's, Schmid's, Nordwall's, Tedlock's. You can all leave. I'll give you your extra 20 assignments. But I'm not going to have you just be disruptive because you're feeling like it. There you go, buddy. Alright, I need everyone to click the continue button. That's there on the left side. Yours will be right here on the left. It's right by the textbook. Oh, come on. It should not take us 10 minutes to get here. Whatever. No, we can go sit at the safe seat or that desk. Alright. I'm going to go ahead and assign you the code I want you to go to. Everyone click on this flip link. Did I give everyone the notes? Or did I stop at some groups?
You didn't give us.
We didn't get it.
Did I give it to you? Oh, I only gave it to one group. Yep, you can close your workbooks and just put them to the side. We put them on magnets.
Well, it's bothering me and distracting me.
I'm not allowed to poke you with something sharp, am I? Well, it's kind of annoying me and Bob. Alright. Let me get to one thing. Alright, I need you guys to look at your notes. And the very first thing we should do is put our name. We need to go ahead, do our heading just like always. So, name, date, assignment is 3-4, and this is 4th block silver. Okay, today's learning goal is that I will be graphing, or I will represent ratio relationships in a coordinate point, or coordinate plane. There's 3 things that you're going to have to do today. 1, create and plot ordered pairs from a ratio relationship. Create graphs and solve ratio problems. And create graphs to compare rates. Riley, or
Don't call her Eliza. You got
Alicia.
No, Elisa.
Elisa. So close. Oh, we'll get it. If it's not there, it's okay. I'll get you there in a little bit. Alright. What you're going to go ahead and do, I need to... Nowhere, just leave it there. Alright. Yep. So I'm blocking your computer, so you have to be following along on your notes. Alright, so first thing, warm up. When we follow these labels, or follow these instructions, important things is labeling our graphs. And so the first thing says, label the x-axis. Remember, x-axis is the bottom one we just talked about. And because we have a table, this is x, this is y. You should label these on your notes. I'm expecting to see what I'm writing on your notes. That's part of your effort grade. So, I'm going to put down here, time, and it says I want to have my scale go by ones. So here's 0. I'm not going to write every single number across the bottom because it becomes kind of clustered. It gets so many numbers, it doesn't look neat. So I'm going to go 1, skip a line, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll do the same thing going up and down on my Y. This is my earnings. And I'm going to go 0, and I can count by 5s. I can see my biggest number is 30. So I'm actually going to go every 2 lines is 5. So 2 lines, 5. 2 lines, another 5, 2 lines, 2 lines.
We can see our lines.
Yeah.
It's okay. Just get it as close as you can. So I went ahead and I put these on there. Now, my job is to identify coordinate points. If I look at my graph, what do you think one of my coordinate points will be? Sarah?
1 to 10.
Yeah, the very first one. X coordinates 1. The matching ratio was 10. What is my second coordinate point? So I'm going to say 1, 10. Alex?
20.
Okay, so 2 went to 20. Okay, so I'm going to go over 2. I'm going to go up to 20. And my third coordinate point. Maddox?
3, 30.
3 to 30. Now, the last thing we do that's important is we draw as straight as a line as we can to connect all these points. Okay? That's an important part because when we do that, it tells us all the points. Now, if you didn't know, here's something that is pretty cool. I mean, this is pretty special, actually. Let me get to that little first point. If I look at this graph, can anyone identify another equivalent ratio? Everett?
3 to 40.
Nope, can't be 3 to 40. No, that has to be wrong because we already had 3 to 30.
Oh no, it'd be 4 to 40.
Okay. So if we did 4 to 40, now I can't fit that on here. But I'm going to go ahead. I know I had you guys do this different. I'm going to erase mine real quick. I'm not going to make you. But I'm going to show you something. Let's say I use red. Let's do it this way. So that was 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay. So then we put our points on, and I'm going to use 1 to 10 was there. 2 to 20 was here. 3 to 30 was here. And then Everett just told me 4 to 40. Do you notice that all of our points are along a straight line?
Wow.
Now, my line kind of got curved, right? In 8th grade, when we did algebra, the important thing that we did was we would use a ruler to get this as accurate as we can. When you get to algebra, and when you're doing some math, your accuracy is very important. So I'm going to fix this on the computer. There we go. Not as good as I can get on my computer right now. Now, can anyone, even if you can't tell me, can anyone come up and show me where another point would be located? Let's use red. Can anyone show me where another equivalent ratio would be found? Patrick?
Well, and it would be here.
Sure, mark it. And where's that at, Patrick?
550.
550. Okay, so 550 is on that line. That's also an equivalent ratio. Okay. How many equivalent ratios do you think we can identify right now on this graph? Peter?
A lot.
Okay, that's not a number. Everett?
12.
12. 6.
Yeah, basically what Everett said. I think
12.
6.
6.
Any amount we wanted. So unlimited. Because lines are continuous and forever.
Okay, you're right. This isn't line, so it could go off forever. But what if I just said only on what we can see right here? I cut this off.
Does it have to be equivalent?
Has to be equivalent. You're right. If the line went on forever, yeah, I can just continue to build. What if I only use this though? Alex? 6. More than 6.
No.
Peter?
12.
More than 12. More than 30. More than 50.
80.
More than 80.
Oh, I found 100.
More than 100.
Oh, I know it's 120.
More than 120.
768.
More than 768.
Any amount we wanted.
Infinite.
Infinite.
Now-
That's a number. I said that. Infinity. You just kept guessing. I'd like to clarify. I said that.
And I'd like to clarify you said it for the wrong reason.
Yes.
Now-
Because you can do any amount.
But he was correct if the lines continued. But I want us to see why this works right now. What if I told you this point right here? Now, it's on the line. Is it an equivalent fraction?
Yes.
It is. I don't know what it is right now. I'd have to do some work and find it. But the line, one reason we graph is when we graph and we draw a straight line, it means any coordinate point on this line is an equivalent fraction to the other ones. Okay? Now, this might come out to be a decimal. It might be 4.24689, and the y coordinate that went with it could be 47 point something. It would have an exact location, but that would reduce to match our equivalent ratio. Every single point on our line is an equivalent ratio. So you can go in and mark them as much as you want, and as long as you're on our line, you followed our equivalent ratio. Okay? Now, one last piece of information, just because some of you might be able to visualize this better. The reason we use a line is to show us data quick. How many coordinate points do you think we need to graph before we draw our line? How many coordinate points do we have to go ahead and plot and graph before?
Make your computer easier.
And why are you playing with your computer, Peter? Instead of paying attention up here, you're messing with that, trying to figure out how to get off of that. Why don't you go ahead and bring your planner, put it up on my desk, since you are having trouble focusing. Next time I'll send you somewhere else and give you other math work, since you don't need to pay attention. How many points do I need to plot before I draw a line?
One.
No. Everett? No.
Oh.
Really? Nope. I do 2 points, that football field, when I made that and I had to cut that paper, I measured, I just ripped it off, and then I measured to get the right length. If I measured just 2 points, and I come over and I measure, I'm going to over-exaggerate. I tally mark here. I'm going to over-exaggerate. I measured the same distance, but I made a mistake. Can I make a straight line out of these 2 lines?
No.
That's pretty straight.
Yeah.
Like, I know I made a longer tally mark, but if I just put a dot here and a dot here, can I make a line out of this?
Yeah.
2 points, make a line. Any 2 points. This is all math. Any 2 points make a straight line. Now, if I want to make sure I have equal distance apart and I'm checking for accuracy, when I do some woodwork and I'm cutting a board, I always measure from 3 parts. When I did that paper, I measured from up here, marked it, measured from up here, marked it, measured from down here, mark it, and then my line has to go through, and if I drew better, it'd be better. My line needs to go through all 3 points. If you go through all 3, you show something's accurate. So get that in your head. Today, you are going to have to graph 3 points. You're going to have to plot 3 points to do your line. Every single time. Okay? Alright, look at example 1. Our examples will not take us very long if you're following along. It says, graphing ratio relationships. For a ratio of 2 quantities, you can use equivalent ratios to create ordered pairs from the first quantity to the second quantity. Okay, you have this in notes. You do not have B yet. I'm going to show the video. Watch, see how they do A, and then you will do B. Maybe.
Use the equivalent ratios 4 to 2, 8 to 4, and 12 to 6 to create ordered pairs. The ordered pairs flour, water are 4, 2, 8, 4, and 12, 6. To graph the ratio relationship, start by plotting the ordered pairs. Remember, when plotting an ordered pair XY, the number X corresponds to the horizontal axis and the number Y corresponds to the vertical axis. Plot 4, 2, 8, 4, and 12, 6. Then start at 0, 0 and draw a line through the points.
Okay, so if you see, flour was 4, water 2, so the coordinates were 4, 2. So that's what we put in. Our ratio of flour to water was 8 to 4, so I did the coordinates. 8, 4. All you did was go and plot. Any questions on that? You're going to be doing it here in a second.
This graph represents the ratio relationship from the table. Part B.
Alright, this is what you have to
Use
do
the
B.
equivalent ratios 1 to 10, 2 to 20, and 3 to 30 to create ordered pairs.
Okay, who can tell me what is one of my coordinate points? Do not use the highlight. What is one of my coordinate points then? Talon?
110.
Everyone should be writing this down. I'm going to go over 1, up 10. What's my second one? 2. 20. Over 2, up 20. What is my third? Marley? 3 to 30. Okay, I'm going to draw my straight line, and then I got a bonus question for you for one piece of candy.
Oh, I love cake.
Okay, if I look at my line, what should be my next ratio? 1 to 10, 2 to 20, 3 to 30. Ethan?
4 to 40.
Alright, so Ethan said 4 to 45. So,
No, he said
we're going to
4
check 4 to 45.
He said
We're
4
going to
40.
check 4 to 45. So, I'm going to go over 4. Let's see, there's 2.5, 3, 3.5. Here's 4. Then go up, there's 35, there's 40. Okay, so it'd be up in here. Is that going to be correct?
No.
I don't know. How do you know it is not correct? How do we know that his answer of 4 to 45 cannot be correct?
Because it's not on the same line.
Okay, because it doesn't hit the line. I'm going to use a straighter line here. If I drew my line, let's see how close I got. We go to our 0. This thing can be so touchy. Come on.
That's close enough.
There we go. Alright, so if we look at this, 4 to 45, that's off. We visually can tell right now this answer is incorrect. Ethan, would you like to try to change your answer?
No, I already said 40.
Oh, 40? 40 is a better answer. Good job rethinking what you said. So, instead of 4 to 45, he's going with 4 to 40. Well, let's see if that one works. Oh, don't do that. There. Alright, so we'll try 4 to 40, or 4 to 40.
55.
Is that on our line?
Yes.
That one would be correct. Good job rethinking, Ethan. I need an example of someone missing it.
Me.
So,
You should have.
can anyone tell me on this graph, what is one of them that will not work? One that will not work. Draylee?
On the graph.
Hmm? No, 4 to 40 works. Ethan just proved that. Alex?
Got it.
Okay, if I go over 2, I go up to 25. Oh, that is not equivalent. Good job, Alex. What's another wrong answer? Bethany?
1 to 30.
1 to 30. Ooh, that is not our line. 1 to 30 is not an equivalent fraction. Good job being wrong. Maddox, can you fail at this?
Technically, you're right.
Huh? 2 to 21. Just barely over it. Barely off the line. It's not on the line.
Technically, we're right.
Anastasia. Huh? 2 to 5 is also not an equivalent fraction. Way to fail at life finding equivalent fractions.
Me.
Alright. We're okay there now. Alright, let's go to the try it. This is where you are going to need your computers.
Wait.
Now, I know. Just leave it where it's at. I gotta show you what you're gonna do.
Now I'm talking about if roses are keyboard too. Not did it.
Okay. You are going to go to this try it. When you go to try it, I think I have to flip you the link again. If you look at your notes, I gave you the table. So it's on the second page. It says try it. Here's this table. The reason you want to see it is because when I go to do this, I'd have to scroll back and forth. Now, if I choose 2 points, my big ideas will automatically make the line for me. But does that mean it's right? No. It will make a line after 2 points. How many do I want you to put on there?
3.
Check. All 3. Because if I do this, ooh, it showed different lines. It did not make one line. I should have one solid line. If you mess up, there's the reset up there. You can check your answer then. Tell you right or wrong. When you're done, you go to the next one. You do the next one. And then you tell me how you understand this. Another real quick thing is, I do know that when you check, if you did 3 plotting points, it takes one of them away. That's okay. Just put all 3 to make sure you're on the right page. Alright. put everyone to this part. If you get the flip link, you would be there.
I'm there.
Yes.
So I get these videos so
No. You don't have to share your work on your notes. All you're doing it is on the computer.
No.
I'll take it, please.
No.
Yep. Okay. No, I'm gonna mark you a double time. Okay. Thank you. Please get started on the work I just gave you.
It's a video. Yes, I'm gonna put it.
Because you didn't pay attention, you were playing with the flag when I sent the
It
flip
said
link.
that I didn't press the flip link.
Not the second time. Because you're in the wrong chapter and everything.
I can do this. We can check. What? I'm done. What? What was that?
Give it up. You both right?
It doesn't have the one.
How do you draw a line?
I've already stated that a couple times.
I'm clicking it.
Alright, so I just realized we haven't been recording. Sorry about that. But let's fill in. Model 3, here we go.
A hot
Fill out
air
your
balloon
notes.
rises 9 meters every 3 seconds. A blip rises 7 meters every 2 seconds. Graph each ratio relationship in the same coordinate plane. Which rises faster? Create ratio tables for each rising object. Then plot the ordered pairs, time, height from the table and use the graph to determine which rises faster. Start by creating a ratio table for the balloon. Balloon rises 9 meters every 3 seconds. So the ratio of time to height is 3 to 9. Add the quantities from the original ratio to produce an equivalent ratio, 6 to 18. Do this again to get an equivalent ratio of 9 to 27. Now create the ratio table for the blip. Blip rises 7 meters every 2 seconds, though the ratio of time to height is 2 to 7. Use the quantities from this ratio to obtain an equivalent ratio of 4 to 14. Do this again to obtain an equivalent ratio of 6 to 21. Now use the equivalent ratios from the table to create ordered pairs. The ordered pairs for the balloon are 3, 9, 6, 18, and 9, 27. For the blimp are 2, 7, 4, 14, and 6, 21.
And then what do you think we're going to do?
Plot and label each set of ordered pairs. Then
Plot
draw a
them.
line starting at 0, 0 through each set of points. For the balloon, plot 3, 9, 6, 18, and 9, 27.
Now, as she's working, I'm just going to talk real quick. Why should I use 2 different colors when I make my lines? Sarah?
So you know which one's the blue and which one's the blue.
Yeah, so I can identify which one is which. Alright, looking at our graph, I let it go just a little too long. I want to back it up so you can't see the answer if you didn't. Okay, there's the lines they drew. Which one rises faster? Looking at just our graph now. Patrick?
The blimp.
The blimp is. Here's height, and the blue line is above the red. The blimp is the one that is rising faster. If you needed to compare ratio graphs or tables, you can also do it here. Here's 6 seconds. I went up 18 meters. I went up in 6 seconds. I went up 21 meters. All right. You can push your notes to the side. I'm going to tell you what you're going to do for your homework. For your homework, you first need to finish up your Desmos. It needs to be turned in today. Then, for your homework, you have these types of questions. You must, I hope people are looking up here because if you don't do this right, you don't get credit. Even if Big Ideas is not telling you to, I'm telling you, you have to show all your work. On number 1, you will have to say, number 1 on a blank piece of paper, you have to draw the table. Okay, you have to draw this table, and you are going to have to show me. Okay, how did I get from 6 to 3? I divided by 2, so I divided by 2, and I get 1. You are going to continue to do this to show me all your work. Now, on the graphing, the reason I'm having you do it online is because it will make your lines for you. On number 2, is there a table?
No.
You must, on your work, show me a table. How many coordinate points do I have to have?
3.
3. This is saying a train travels 45 miles per hour. So I'd say distance, oops, there it is, distance on the left, time is on the top. Remember, x, this is y. Distance is y, time is x. So in 1 hour, I'd go 45. You then have to find the other 2. On number 3, is there a table?
No.
So you need to create one on your notes. Number 4, is there a table?
Nope. Yes. Yes. Yes.
Yep.
No, I see it.
All you have to do is graph, no work. Number 5, do you need to show work?
No.
Nope, just graph. Number 6, do you need to work?
No.
Nope, just graph. Number 7,
No.
just graph.
No.
Number 8,
No.
number 9,
No.
number 10.
Yes. Yes.
4 questions you have to show work on.
So.
All right?
Wait, what about the 8?
No.
A group, you have a little bit different. All right, Desmos first. Turn it in. Your computers are unlocked. Do your Desmos first and turn it in.
Yay!